Okay, I'm looking at section 5.2, using ratios to find quantities. So for example, we're all used to sharing something out for half for you, half for me type thing. That's a ratio of 1 to 1. It's very easy, but ratios can handle much more complicated splits over sort of 2, 3 or more different splits depending on what the storyline's about. Let's start with some basic ones. I've got to divide up these numbers and quantities into the ratio of 1 to 2. So I'm on page 85 and question 1, let's go for question 1D. So 1D, page 85. I've got to split off 6 litres or share out 6 litres in the ratio of 1 to 2. Now 1 to 2 means I must have 3 parts. Alright, because 1 plus 2 makes 3 parts. So each part must be worth 2 litres, because 6 divided by 3 is 2, and therefore if I go back to my original ratio of 1 to 2, for the 1 I'm going to get 1 lot of 2 litres, which is 2 litres, and for the 2 I'm going to get 2 lots of 2 litres, which is therefore 4 litres. And I'm correct because 2 plus 4 makes the 6 in the question. I think I'll do one more over here, going straight into question 3. It's a bit of a storyline behind it. It says in a savings account the ratio of the amount invested to the interest paid is 50 to 1. So I've got some amount invested in the bank and they're going to give me some interest, and the ratio is going to be 50 lots to 1 lot, and the question asks approximately how much is the interest paid on savings amount that has £10,525 in it. So £10,525, and therefore how much interest will they give me? That's the question. Alright, so I've set up the ratio. A couple of ways I can do this. I can say x divided by 1 equals 10, 5, 2, 5 divided by 50. Now I know that x divided by 1 is just x anyway, and now I need my calculator to do that little bit just there. So switch it on. 10, 5, 2, 5, divide that by 50, and I should get paid £210. There's my pen somewhere. There you go. 200. It's frozen. Okay, £210 and 50p. Alright, very important to put the 50p there. If you don't do that, it looks like you don't understand money. And plus, remember in this new exam, you get marks for the quality of your written communication, and there'll be at least 2 of those floating around on each paper, I believe. So it's definitely worth having that. So be accurate with it, not 210.5 just because it's what the calculator says. You've got to do what it says. Alright, it's obviously got to be sensible about it and include the pennies where possible. So that's how much interest I should get. Now I'm going to go to the next page because the next question is going to require a little bit of thought. It's a bit more involved what we've done at the moment. It says that bronze coins can be made of copper, tin and zinc. So here I go, copper to tin to zinc, and it's in the ratio of 95 lots of copper, 4 lots of tin and 1 lot of zinc. Now clearly add that up, gives us 100 parts, doesn't it, to the whole thing. Alright, and the question says how much of each metal is needed to make a kilogram of bronze. So a kilogram, you should know, is 1,000 grams. I'll just write it over here. And how much of each metal? Well, I know I've got 100 parts. Should find what 1 part is worth first. So divide by 100, and that will give us 10 grams per part. So for the copper, we have 95 lots of the 10 grams. Well, that's 950 grams of copper required. For the tin, we require 4 lots of that 10 gram part. So that's 40 grams of tin required. And zinc, well, it just says 1 lot, doesn't it? So that'll be 1 times 10, which will be 10 grams. Now, if you just check this, just test it out, that should come to exactly 1,000 grams, and it does. So we know we've got this correct. Alright, well that's all that was part A. Part B says how much of each metal is needed to make 10 kilograms of it. Now 10 kilograms is obviously 10 lots of 1,000 grams, or 10 lots of 1 kilogram. So if I multiply each of these by 10, I should get the correct answer, shouldn't I? So 950 multiplied by 10 would give me 9500 grams, or 9.5 kilograms. That's to make 10 kilograms of this particular batch of coins. Next one, 40 grams times 10. Well, that's going to be 400 grams for the tin. Keeping it all consistent, that's 0.4 kilograms. And last of all, the zinc is 10 grams times 10. Well, that's going to be 100 grams. And 100 grams is 0.1 kilograms. If you do the addition, you will see that does in fact come to 10 kilograms exactly. No point writing down the 0.0. Doesn't do anyone any good, does it? Question C, very easy now. It says how much of each metal is needed to make half a kilogram. Well, really easy. Copper, well, I know that I require 950 grams to make a whole kilogram. I'll just divide that by 2 to make half a kilogram. That's going to be 475 grams. Just looking at the clock there. Where were I? Tin. It's going to be 40 divided by 2 to make half a kilogram. So that's going to be 20 grams of tin required. And zinc is going to be 10 grams divided by 2, and that requires 5 grams. Again, just to test this out now, if we add up that little lot, we should get 500 grams exactly, and that's of course equal to half a kilogram. Is that alright? Okay, and finally, part D says, how much zinc would there be in a grams? Okay, how much zinc would there be in a coin that weighs just 6 grams? Well, if the whole thing is 6 grams, and zinc, going back to the original ratio, is just 1 part out of 100, I want 1/100th of the 6 grams. Taking it further, that's 6 over 100. In other words, 0.06 grams of zinc. And that's just to make a 6-gram coin. Alright, so not much zinc in it, but the maths is correct. And I think I'll leave it right there because I've reached the stage I want to reach, and that is 5.2 done. So now we know how to share out quantities in a given ratio, and this question, question 6, was particularly nice because it's a real life question and it's quite complicated, lots of bits and pieces, and I'm really happy with it, so enjoy that.